Again, thank you for coming to SUSE Exchange, where we're going to be discussing how we can modernize your guys' business. Just a quick introduction. My name is Austin Iveson. I am a solution architect here at SUSE. I've been with the company for 3 years now. Actually, was on the developer side for a product called Rancher, which we will be talking about later. And I have the lovely Jamie Speck, who is the organizer of all this here. So, she's the reason that you guys are all in your seats at home watching this webinar. So let's go ahead and get started. I'm just going to go through some slides here where you're going to have some interaction with demos of our Rancher product here in a moment. But let me just kind of set the stage here. So as time goes on, we're going to continuously have to modernize our business. And as we can see with things like ChatGPT coming into play, we've definitely integrated that into our day-to-day workflows by now. So let's start off with a definition of modernize according to ChatGPT, which it means to update, improve, adapt something such as a system or method using current technologies, methods, or designs to optimize its performance, functionality, and efficiency. So there's no doubt that we've been affected by technology. We've been affected by things like AI, but that's not the only thing that we interacted with in regards to technology. So for instance, I'm going to set the stage. Imagine yourself as an individual that wants to create, produce, and perform music. How has music and its delivery changed over time? Well, here on the left, as we can see, we have a conductor. They're managing multiple musicians with different instruments. Each of them have their own section. You've got the strings, the brass, woodwinds. And when the creator of this music wanted to write for those specific sections, he had to know the music theory, he had to know how to write for orchestra sections, and so on. And so then once those were written, each musician had to then play it all together. They had to come together, repeat, practice over and over so they could make the best possible music. And in the meantime, in order to promote and distribute these songs, there was no solution. If you wanted to hear the song, you had to go to the concert with like a full orchestra, the whole thing. It was a monolithic experience, if you will. So think of that as kind of like the old IT systems where they built software made just for them. And if you wanted to use the software, you had to go to those terminals where they were installed to perform operations. And by contrast, on the right, you can actually see a woman here. She's creating music with various pieces of equipment. She's using a computer to create the track. She creates each layer even without any physical instruments being involved. So maybe she doesn't even have to know the music theory as intimately as the individual on the left. And she doesn't know how to read and write for each section, but it's been abstracted away into these layers of music that they're creating. And that's a lot like today's developers. You've got different coding languages that have made certain things easier. So like Golang for networking type solutions, or you've even got low code and no code solutions to iterate quickly and commit code on a daily basis. I mean, there's so many things that have modernized in that sense. And again, this covers the creation part of music or application or software, and it lets you take a look at the distribution of and the capabilities of that distribution. So then how did music then start to get delivered? Back in the 90s and 60s and 70s, we had other ways to listen to music other than just seeing it in person, right? At one form factor for analog was vinyl. You had one song on each side in the beginning, and if you wanted to listen to it, you'd have to have a turntable, which wasn't super transportable. You just had to have the right equipment in your room to listen to it. And you wanted to listen to 100 songs, you had to carry 100 vinyl records, which was heavy. Then radio was invented, and we could put a microphone on the turntable and we could share the music by radio waves. And there are still some instances where customers are running one application on one server. After that, another revolution, another form factor, the cassette. So if you think about it, you can create your own playlist by recording the songs from the radio or from another tape in Magic. And you can support it in your pocket using a Walkman. And in the IT world, we started installing multiple applications on servers, and the microcomputer came inside our homes. So we then moved to the digital era with like CDs, and we said goodbye to analog and hello to digital. So this media is more robust, and it's very similar in the sense to virtualization inside the data center. So we can deploy, multiple songs or multiple applications on one piece of hardware with great quality. And as the evolution of this all continues, we start getting formats of MP3, FLAC, all these digital forms of this music, and this sounds a lot like containerization. So now that you've got a lightweight piece of music that you want to distribute to a lot of people at once, that there needs to be a place to do that. And so now that you've got loads and loads of music and people are able to produce music from their home, how did it become scalable? And that's when we solved that problem by building platforms. So as platform engineering could be compared to platforms of music, we don't care about the form factor anymore. We don't care about a lot of these vinyls and cassettes. It's for enthusiasts of a nostalgic era, but now we host all this music on platforms such as Apple Music, Spotify, as you can see here on the right, and that's where those all live. And if you want to listen to the new music, you're going to be integrated into essentially a serverless solution. And this allows for people to pull tracks from the cloud, or again, essentially you don't have to interact directly with that server as a developer of music anymore. You can just create that music, upload it to one of these platforms, and then people can consume your content. So yeah, but even with all these platforms and all these form factors, there's still one important mandatory piece that essentially comes when you want to create a playlist, curate some sort of environment, and that could be a DJ. So I like to think of the DJ as like, oh, the platform engineer, right? They play songs, they create a flow, considering you have to create a workflow for people to experience the end application. So the DJ essentially does the concerts. He plays CDs from songs he plays songs from CDs or these mix tables. He may plug in his phone, as you can see on the screen, plug in his laptop or her laptop, and then you have to mix that all together. So you have, in this sense of in the IT world, you have to deploy to multiple places. You have to make a quick adjustment, and once you get feedback from the dance floor, you can change things on the fly. So say your developers need a very specific application brought up. Well, that's where these platform engineers, that's where this DJ would come into play. And so to step away from that more artistic take, that more from metaphors and such and whatnot, but let's go in and talk about the actual modernization of the IT industry. So as we can see here, we've got 4 quadrants, and these specific sections talk about everything from the development process. We've all experienced waterfall and agile, and then move those into the DevOps methodology. So this could carry on from the way that you're deploying your applications from a Linux server to VM, these virtual servers, to then on top of Kubernetes clusters with a container of those applications. So again, and with SUSE, we allow you to support and build on top of your infrastructure to deliver business critical applications such as like SAP. And we modernize our portfolio to work alongside our customers that modernization journey, because some of you may be still using virtual servers, so you might need a hypervisor in that sense, where we have solutions for that. But we also have an integration with Kubernetes clusters in that same sense. We also have a Linux distribution that might sound like the vinyl record did back in the day, but today we are also modernizing our Linux distributions with the sense of using SLE Micro, which is like an immutable low footprint OS, or we may have base container images, and we're looking, if you want to take a look at how we build containers, and you can base your own containerized applications off of our based images. And again, we're looking forward. If you're familiar with our product, we have Adaptable Linux platform. So it's essentially an OS built with containers. And again, this can all be done both on premise. You may have situations in the cloud or on edge, but you can do all of this at a hybrid model, and you can take care of your security stack, your OS verification. You can go through the supply chain, and we support the container life cycle security. If you've watched my compatriots, my coworkers presentation at our last webinar, he did a great security webinar, and we're on to the next step of modernizing that. So let me go on to the next slide. So again, as SUSE, we are interoperable. We are an open source company. That is our ethos, and it always has been for the last 30 plus years. And we collaborate with individuals. We like to collaborate with our customers as well. So if you have partners, we'll work with them, they'll work with us. And it's just like an individual in the music industry. They want to create the best kind of music. No one's doing it alone. Everyone's working together. So it makes a big ecosystem of partners, of collaborators, and that we believe that's a huge key to our progress. So we want to be that interoperable piece that you guys are able to deliver your applications via your own methods. We know that you may need multiple Linux distributions, you may need different Kubernetes distributions, like you may need, again, Kubernetes clusters and virtual machines all at once, and we provide solutions for that. So let's talk about what we're going to do in a demo real quick, because now that I've given you guys a quick slide introduction to what SUSE is, we're going to dive in, and I'm going to essentially show you guys Rancher. As you can see here, this is Rancher Prime. This is a DJ managing Kubernetes clusters, essentially, right? And so, yeah, if you're familiar with Rancher, it is a platform to manage from a single plane multiple Kubernetes clusters, and I will just go ahead and get started with what that looks like. So as we can see here, I have a Rancher instance up and running. I'm signed in as an admin. This is the very specific use case for pretty much everyone out there. This is like, hey, you're the head of your platform engineering, you're the head of DevOps or the DevOps team, and you need to manage all of this on your IT landscape. So just to talk about what this page is for a second, we have multiple clusters here, 1, 2, 3, 4. As you can see, this local cluster is actually where Rancher lives. So again, Rancher is a tool to manage Kubernetes clusters, but Rancher in and of itself is an application that is deployed on top of or into a Kubernetes cluster. So as you can see here, that's where this local cluster is, or that's where, sorry, Rancher lives in this local cluster. We've got different versions here. We've got different providers of clusters. So we have EKS and AKS, and then Amazon EC2 instances using the RKE2, which is our Kubernetes distribution. And I can actually show you what it looks like to create a Kubernetes cluster. So if I come over here and click this create button, I could also come into this global menu on the left and click on cluster management. But I'm going to click on this create button for now. And you're going to immediately have some options here. So to explain what we're seeing from the top to bottom, we have some instances of hosted Kubernetes providers. So you can actually pick to host an EKS cluster, an AKS cluster, GKE, Oracle even if you wanted. And you can actually define what drivers you're using over here and add other cloud providers. But let's say you want a little more depth of understanding or depth of you know, operation into the Kubernetes cluster. These cloud providers, they take away your management of the control plane, and you essentially will have the visibility of the worker nodes in Rancher, but they take care of all the control plane. But say you wanted to, you really understand Kubernetes and you want to understand the control plane aspect as well. Well, you can actually come into these options here, which are essentially provisioning new nodes and creating a cluster using RKE2. Those nodes are going to exist as either Amazon EC2 instances, DigitalOcean droplets. In fact, if you have, VMware and spin up virtual machines, you can use vSphere to bring up clusters, and you'll have downstream Kubernetes clusters is what we would call them, right? Because they're downstream from Rancher. You're working from Rancher. Every cluster you provision will be downstream from there. But say you wanted to work with our HCI hyperconverged infrastructure solution in Harvester, you can actually spin up virtual machines in Harvester and use those VMs to bring up Kubernetes clusters as well. There's a lot of options here. Again, we want to be interoperable. We want to be the person that you can use all sorts of cloud technologies, all sorts of on-premise technologies as well. And in fact, if you just wanted to deploy a script essentially right into a bare metal node that you have access to, you can do this custom option. You already have that node up and running, and boom, it's good to go. But I'll show you what I did for, let's say, Amazon EC2 here. So this is what's going to happen. When configuring, sorry, when configuring Kubernetes cluster, you have to go through and pick things like, the instance type, or the Kubernetes version, the CNI, etc. But what we're going to do here is we're just going to provision a quick cluster that's going to have, let's just say, Modernize. I'm going to give it a name. I'm going to change this machine pool to be named workers. So this is going to be the working machine pool. I'm going to deselect control plane and etcd, because as we're familiar with Kubernetes cluster terminology, or Kubernetes vanilla Kubernetes, there's workers, there's etcd, and there's control plane nodes. I'm going to just give this machine pool 3 worker nodes. I'm going to assign a VPC that I've previously configured for this, and then I'm going to add one more machine pool, because as it stands, I don't have a control plane or etcd to interact with this cluster, so I need a little more sauce. So let me get this, and I'll call this the master pool, because this master pool is going to contain 3 machines, and it's going to have a co-located roles with etcd and control plane. I'm going to select that same VPC, and then I'm going to come in here and do a little cluster configuration for you guys. I'm going to change this down to 1.27. I'm going to leave this default container network interface, but as you can see, we do support Cilium, Canal, Flannel. Cilium if you need that ePBF and you have those network policies that you want to set in there that you're familiar with. I'm just going to leave the default for now in Calico. I'm going to come over here and I'm actually going to do some more configuration. I'm going to add a member to this, and I actually have some pre-configured users using RBAC to essentially add a read-only user, and I can demonstrate what that's going to look like momentarily. So there's going to be 2 members in here, admin, myself, this cluster member, which is a read-only member. And then, again, we talked about the modernization of delivering applications. We talked about, waterfall to agile to DevOps. And so how would you interact with DevOps on the creation of a cluster with Rancher? Well, we have a tool called Fleet that interacts with labels. So if I just add this label real quick, GitOps true. So I've went ahead and pre-configured this, and I'll show you what that looks like in a moment. to configure our continuous delivery tool, which again is called Fleet, to deliver applications to this cluster. So I'm going to click create now, and we're going to let that sit. And what's going to happen is it's going to take us back to this page, where we have multiple clusters running, and we can see that, we've got this new modernized cluster coming up, and we can dig in and see things like the provisioning logs. We can see those machine pools that we defined. And then let's quickly go over what I did with that instance of Fleet. This will take a few minutes, so I don't want to just have us stare at this page, because again, your time's valuable, my time's valuable. So let's kind of keep this short. So as you can see here, this is Fleet. This is our continuous delivery tool. And what I had done was added a Git repo Fleet demo, and it's failed right now because this is currently looking to dial to that downstream cluster. And what had happened was I selected a cluster group, and if you come in here and configure this cluster group, it looks for cluster selectors, GitOps, enlist, true, and once that cluster comes up, it'll automatically detect that this label, because again, you just saw I added GitOps true to that last cluster that is being created, and it's going to deliver a whole bunch of applications that we have in this Git repo. So, if we just do a quick force update, boom, and it's good to go. And so then let's come back and kind of take a look at how we deploy applications manually or through our app catalog for you guys. So I've went ahead and created multiple clusters, as you can see here, to again show you that you can work within your bare metal instances, different clouds. And so let's go into this EC2 demo cluster that I have prepared for us, and we can immediately see some interactions with this cluster. We've got the ability to see the pods and applications and service discovery tools such as ingresses and what services are being deployed. So for now, I'm going to show you our app catalog and how to add things to that catalog. So if we come into apps and then repositories, we're going to have some repositories that are innately built into every cluster that you spin up using RKE2 inside of Rancher. And I'm going to click create, and I'm going to name this, let's say webinar. And I'm going to grab a quick GitHub repo. Let me see if I can find it. Looks like I'm gonna have to type it out. And if I click create here, I've now added a new repository to our charts. I haven't shown you charts yet, so let's go take a look at that. So as you can see here on this web page, we actually have some charts that we manage here at Rancher. So, we give you access to Prometheus. We give you access to New Vector, Longhorn. These are all charts that you can deploy with a click of the button. And Istio for your service mesh. So say we wanted to deploy, one of our applications that we have SLAs for. You can actually come over here. Let's do monitoring real quick so you can actually see inside of this cluster. I'm going to click install, and I'm going to then select just the system project. I'm going to go next. I'm going to look at some things real quick here. This is essentially demanding. We don't have a lot of resources in this cluster, so I didn't want to spend the big money, but I'm just going to have the requested memory and CPU get a little bit lower, and I'm going to click install. And again, this is Prometheus and Grafana. It gives you the ability to see, if you've interacted with Prometheus, you're going to see all sorts of new metrics. You're going to have dashboards pop up. And if you actually come over here, there's other applications that you can install. If you get Rancher Prime, we actually have a whole catalog of applications that if you get a subscription with Rancher, you're gonna have access to all of these different charts that we build out for you guys. These applications, they come from a trusted source. You're able to build out Harbor, you're able to build out Grafana, Git. We're adding Kubeflow to there, kubectl. All these applications come again from a trusted registry that we update and we keep safe for you guys. So again, so securing that supply chain. So I just wanted to touch on that. So we're just going to wait for this to deploy, and as we do that, I'll come into here and actually set system namespaces. And as you see, I've filtered out, and I can now see applications that have been installed, and Rancher monitoring, which we just installed, has shown up. But let me quickly digress, because we did add our own repository that we wanted to see inside of this charts catalog. And as you can see here, there's a filter. So I'm going to deselect the ones that come. I'm just going to deselect all of them, and then I'm going to add the webinar filter. So you can actually come in here and quickly, again, these are all applications that we have in our GitHub repo and built out, so you can have like a form instead of having to interact with YAML per se. And we can click install just like we did. And I'm going to put this into a namespace. Let's make our own, create a new namespace. Default, and then all namespaces. That makes sense. All right, so we're just going to do default, and I'm going to name this just Rancher demo real quick. It's going to be some fun little endpoints, and we get this installed. And all of a sudden, we're going to have this application up and running. It's going to create an ingress for us. It's going to mention pretty much all of these applications, and we can see over here, we actually filter by only user namespaces. We'll start to see an application get deployed, Rancher demo, as we can see here. So, to touch on a few things real quick, we've got this deployment of Grafana that's successfully downloaded. So that means if we wanted to come into these workloads again and check this out, you can actually start seeing information on these workloads, both on the dashboard of these pods, or for instance, let me just do a quick refresh of the page so we can reload, and I can show you the monitoring application that has now been installed. So this page didn't have this option in this menu. So if you come over here, you've got Grafana ready to go. The metrics are running. You can come into Grafana, you can federate multiple clusters and have a dashboard ready to go for your environment, for your team, for multiple clusters, whether it's, again, if you're that platform engineer, if you're that DJ trying to orchestrate and bring everyone together and you want to have visibility into those clusters, you can do that with Grafana. So yeah, it's a quick and easy installation of that. And then if we wanted to even dive in further and look at the pods that we just installed, you could come in here, click on these little kebab menus, and you can do something like execute shell, and you can start running commands in that individual application. You can actually come in and look at the logs real quick and see, oh, look, is it getting the requests that it needs? Oh, I absolutely have the visibility to do that. And this is that, again, that quick demo of the application that I just installed. So we've done that. I've shown you some applications that you'll have access to with Rancher Prime. Again, get it from a trusted source. We maintain these for you guys. We're adding Kubeflow to the list, and so forth. So to continue on, we should now have another cluster up and running. And as you can see, that Modernize application, or that Modernize cluster that I just barely set up for you guys, it's already up and running. It's living in EC2 right now as we speak. And if we come into these pods, well, I labeled it. Yep, I labeled it. And because my fleet continuous delivery tool is looking for those labels, it took all of these applications and it deployed it without me having to touch anything else. And obviously, you can, automate a lot of these processes with continuous delivery through GitOps methodology, or, you can start interacting with our APIs directly. So I would like to just show you guys, like, if you look at the references, you can build out and manage all of these resources directly with our API. And we're continuously opening up our APIs to the public, so you can actually, go and check out the API quick guides scheme. These are all based off of open API schemas. So again, we want to be able to work with what you guys have worked with in the past and in the future. So just a quickly wanted to touch base there. So again, to talk about a couple of the things that we did, we added a label. It deployed all of these applications without us having to do anything. We also did something where we added a user. And if you come here in this cluster, up in the dashboard, you select cluster project, cluster and project members. You can actually see there's a user here. And so I want this user to be a read-only user of this cluster. So I added him to this cluster, him or her. And now if we look at this, this is signed in. If you click in this top right corner, it says read-only. If you look back at this previous page of Rancher, you can actually see that this is the admin page. So what does that mean for this person that has the read-only? Well, I haven't refreshed the page yet. So if I actually refresh the page, that read-only user, this is the same URL for Rancher, same URL, rancher.v0hero.com. V0 is a reference to rock climbing, if you're familiar. Anyway, that's a tangent for another day. And this read-only user only has access, again, read-only access to this application. So, one thing we have built into, read-only access to this cluster, therefore read-only access to the applications therein. So, we've built in a kubectl shell, so you would not be able to do like kubectl create pod, and you would see it says, you're not allowed to do that. This is a read-only user. You can also come over back to this page and see that this admin does have access to the kubectl shell. It brings up this shell as the admin, so you have all the administrative privileges. You can actually download the kube config of this application, just download it, and then you can also copy it to your clipboard. So if you wanted to go ahead and paste this into your own terminal, you could take this kube config, start interacting from your own terminal instead of being contained within Rancher, and start running kubectl commands. You can do all of that from there, again, as an admin. So, some things we've went over, just adding a user to a cluster. We've used Fleet to have applications up and running. And now let's take one last look at maybe these services that we have created. So all of these services that you can see, we have the front end application, we have both the Redis and master slave up here delivering content via these cluster IPs, and we have this node port here, so you can actually add a guest book and say hello and submit, and so people could come in via that node port and actually interact with this clusters via that node port. Obviously you wouldn't want this to have the node's IP address, but this was just a quick demonstration to show you. It's like I already have an application that automatically deployed that is exposed to the internet. It is ready to go. So the same concept with your applications can happen just using a few commands, a couple of minutes, and you've got another cluster up and running. And heck, you could actually tear this cluster down and you could continue on your day, spin up another cluster with the same content, serving the same things that you may need in the future. So to talk about a little bit more of our cluster management, let's say this cluster, I really like to stay as close to upstream Kubernetes as possible. So we need to upgrade this cluster. So if you actually look at this, there's going to be some options here. You can take a snapshot. Highly recommend taking a snapshot. What this will do is allow you to either restore from a previous snapshot of this cluster. It's going to go through all the etcd, configure all that. So say we wanted to upgrade, we now have a snapshot built into Rancher that is actually not tied to this downstream cluster. It is tied to this Rancher cluster here. So therefore, you would be able to restore from that snapshot. Now, let's upgrade this cluster by going into this edit config. And with Rancher Prime, there are tools. I'm sure some of you have heard of Cluster API. So if you look at Rancher Turtles, CAPI, the Cluster API will actually allow you to build clusters and also manage the life cycle of those clusters in an automated way. So you can automatically configure and build clusters, you can update them. So this manual process I'm showing you right now, where you want to upgrade this Kubernetes cluster by coming into edit config, selecting the Kubernetes version, and then selecting save, it'll start doing its thing. We'll start seeing a rolling update go on. They can cordon the nodes, drain them, put the applications onto other aspects, other nodes. But again, that process, that was some click ops there. But through the introduction of CAPI, you can actually manage that from just a simple operator. Heck, if you really wanted to get nitty and gritty, you could make Kubernetes YAML files, deliver them via Fleet, and just manage all of that through a GitOps methodology. So as we wait for this, I'm going to actually show you a little more things in regards to essentially the RBAC policies, bringing in other consumers of the end product that's in Rancher or other administrators. So if you come into this users and authentication, I have 3 users that I've created myself. You can obviously stick with RBAC. We have a ton of base configurations that you can do. But say you obviously might have an authentication provider built into your guys' ecosystem. Well, we support SAML, LDAP, and yeah, so if you wanted to use GitHub to sign into Rancher, you would be able to do that. You could use Azure AD, and then you'd also have access to things like groups. And groups is a cool little methodology where you can actually take, your DevOps team or your developer team, throw them in a group, and then if you remember when we went to this, let's see, this cluster here, and we looked at the project members, a nice little group would show up when you click on add. But again, I can't afford my own authentication provider for my demo purposes. So again, this would just have to be something that you can tell. You just add those cluster groups to this, and it would show up something like, the admin group, and then you'd have everyone that is built inside of, your authentication provider as admins will have access as either a member or an owner of that cluster. It's kind of a step back. We briefly talked about the RBAC policies, but we had some time to kill while we waited for this to upgrade. And as you can see, this is already getting there. So if we come to cluster management, we might have some notifications here. And heck, if we wanted to also demonstrate some interesting use cases with this demo here, the EC2 demo, I forgot to show you guys all of these awesome graphs that get built out for you guys with Prometheus and Grafana. And boom, voila. So again, some of the things we covered today, we talked about how you can use an auth provider. We've talked how you can bring up Kubernetes clusters through the forms. Briefly discussed how you can actually create that automatically. So you can automate away the creation of clusters by using CAPI. This is distinctly a tool used in Rancher Prime, so you need a subscription. But again, we're providing that for you. We're providing applications for you. We're providing the API references so you can actually interact with our open API schema APIs. So interact with Rancher's APIs directly. So let's go back to home. As we can see, this is now active, and we have fully built out and upgraded and deployed onto this Kubernetes cluster, all within the time that we've been here today. Like, oops, I wanted to click on that. 20 minutes, and I've shown you how to deploy, upgrade, all of it. So now I'm going to take it back a step. We're going to go into essentially the wind down. The last bit of this presentation is going to be about what we have in regards to generative AI. So if I can actually get my application to click next. So one tool, we talked about it early on. I inputted what it means to modernize into ChatGPT, and we had a lovely response. Some of those, was it a hallucination? If you've interacted with ChatGPT, it's not always the best, but it's sometimes really good, and I use it in my workflow. So how can you use that in the workflow and help modernize and come to the current standards of what it means to interact with IT? Well, we built out a Rancher assistant for our Prime users. And as you can see here, if you look at this top right corner, there's this little Rancher AI assistant, and you have a whole AI dashboard. And essentially what that is it uses natural language, like all LLMs, all these GPTs you're interacting with, to do things like help you create an RK2 cluster, and it supports other languages as well. So this AI will respond with a list of instructions if you want to create an RK2 cluster. It talks about how you could do that with just RK2 with EKS, shows you how to do it within the UI, sets up your entire ecosystem so you're actually able to work with Rancher a lot quicker and adopt it. Your teams will be able to essentially manage multiple clouds, multiple Kubernetes clusters, and this will just speed up that process. Again, and all of these commands get returned by the AI assistant, and they will be shown to be running. So if you wanted to actually look at that kubectl command, you could interact with it directly, and it would start running these commands, help you manage your Kubernetes cluster. So again, the time to resolution will be very quick. And instead of having to investigate and navigate all of those issues with the cluster, you could start, doing a bunch of troubleshooting using that AI. It'll help you direct the AI insights into each of these pods. It'll detect the CPU load for you, etc. So again, that is pretty much where I stand with this entire demonstration. This AI will give you actionable insights into both the pods, both into the cluster deployments. It'll help you load balance by interacting. It looks like I am going to be giving you guys a little bit of your time back, but again, thank you so much. And if you ever have a need to, again, accelerate your business, we have another SUSE Exchange webinar coming up. Please scan this QR code, register, enjoy, and I'm going to just double check and make sure if there were any questions in the chat. Doesn't look like it. Cool, awesome. I hope you guys had a great time. Thank you so much. Again, my name is Austin Iveson. Please register for our next webinar. Reach out on LinkedIn if you want. If you have any questions surrounding Rancher, we have also, if you're looking to displace your current VM technologies, we have Harvester, which is an option. I like to shout this out right now because it is a hot topic. So if you wanted to, work with VMs as well as your Kubernetes workloads, there's a lot of discussion out there with VMware doing what they've done. post Broadcom. Again, feel free to reach out. You can find me on LinkedIn. And yeah, and thank you so much, guys. Have a good day.